Wi-Fi, protected access, and moving to a AAA server. If you and I go to a coffee shop or a restaurant that has Wi-Fi, especially free Wi-Fi, there's very likely to be zero encryption present. For example, this is our computer, here's the access point, there's the rest of the world, and the traffic between us and that access point on their guest network is very likely not encrypted. And that's why it's a good idea, if you ever do access a free Wi-Fi network, to run some type of a VPN tunnel on top of it. So for example, if you have the headquarters office, you're at a free Wi-Fi location, you get the layer 2 and layer 3 connectivity via that access point and the router that's behind it connected to the internet. But then you immediately launch some kind of a VPN, either an SSL VPN or using IPsec. So all the data that you're sending is being encrypted. And that can protect you right here, if somebody's eavesdropping, from being able to see your data. But you know what? Besides, free Wi-Fi, virtually everything else is going to use some type of encryption to protect the packets on that little leg of their journey between the client and the access point. Shortly after wireless started going mainstream, there was some technology implemented called WEP, and it used a pre-shared key to both authenticate people as they got onto the network, as well as being able to use that key or some kind of a subset of that key to encrypt the data as it went back and forth between the client and the access point. Now at this same time, the IEEE was working on some standards that would really improve the security, but they took several years to get cranked out. So the Wi-Fi Alliance, being a huge push in the security direction, came out with something called WPA, Wi-Fi Protected Access. And what it did, it says, let's go ahead and use TKIP. TKIP stands for the Temporal Key Integrity Protocol. And it uses something called an initialization vector, or IV. If we use this number as part of the math that goes into the encryption, and we change this number for each and every frame, it makes the encryption that much better and that much harder to break. So WPA, TKIP comes on board for better security, and optionally WPA states that you can also use AES, but it was optional. It didn't have to be used. AES is a symmetrical encryption algorithm, and it stands for the Advanced Encryption Standard. Now eventually the IEEE came out with their standard for security, and they called it 802.11i. That's their standard for wireless security. And the I, you can remember that by thinking, I can now secure my wireless network using 802.11i. There's also something called WPA2, as in new and improved. And if you squint and look at the two standards, 802.11i and WPA2, they are virtually identical. I mean, you could probably find something to argue with a friend about, but by and large, they're the same animal. And what they bring to the table is this. We're going to use AES, which is now mandatory as part of WPA2/802.11i. And we're also going to use CCNP, which, among other things, adds some additional tricks to the initialization vectors. And CCNP itself stands for Counter Cipher Mode Protocol. But at the end of the day, it improves the encryption and confidentiality of the encryption being done, and it's linked into AES as well. So sometimes you might see AES, CCNP, and there might be a dash in between them, or they might be separate words. But that's what 802.11i and WPA2 primarily bring to the table. Now, I completely get that one size doesn't fit all. For example, if we're in our home office, we may not have a AAA server to go ahead and call upon, and we might not have a wireless LAN controller. Instead, we may just have an access point. So here's Bob at his house. We have the access point, and we are connected through a router of some type, and that connects out to the internet. So without the wireless LAN controller or the AAA server, we are not going to be using 802.1x. Instead, it's very likely the access point is going to have a pre-shared key. Bob's computer is going to have a pre-shared key, and we're going to use that. But the cool thing is that with WPA or WPA2, there's a couple different flavors of it. We can use enterprise or personal. And all that means is, if we're doing personal WPA, it means we're likely using a pre-shared key that's configured on our access point as well as on the client computer. Now, if you do have a wireless LAN controller, there are also options for pre-shared keys there, but it's not the best option. In an enterprise environment, we're going to have a centralized security server, like a Radius server that's running ACS from Cisco or ICE from Cisco, or some open Radius server. And the beauty of doing that is that when clients connect here, there's a supplicant activity talking to the authenticator. From the AAP to the AAA server, the protocol used is Radius. And once the AAA server authenticates that user, the AAA server can go ahead and hand out keys. And the keys won't be the same. So if I have Bob, Lois, Sally, and Jeff all connected, each one of them are going to have different keys, which makes the encryption, if somebody's eavesdropping, even that much better. And that leads me to this topic right here. A PMK and a PTK. What the heck is that? A PMK is a pairwise master key. So when the AAA server authenticates Bob, the AAA server can hand out a pairwise master key that the AP will have, and he'll know I'm going to use this pairwise master key associated with Bob, and Bob will also have that pairwise master key. Sometimes that's also called the session key, or sometimes just the key that's handed out. But there's actually one additional step with WPA that I want to share with you, and that's this. If we just use that key for all of our encryption of the data, it's potential that somebody who's listening to that data long enough and has enough CPU power could possibly reverse engineer what that is. So after Bob has authenticated with the AAA server and the AP in memory and Bob in memory both know the session key or the PMK, the master key, they can use that and they can do a four-way handshake. And that's right here. I'll put it in blue between the access point and Bob. So they have a little back and forth, 4 packets worth. And from that, they can generate something called a pairwise transient key. And they can take that pairwise transient key and they can chop it up and divide it and use it any way they want to for whatever function. So sometimes we'll hear somebody use the term of keying material, which is just referring to the set of secrets or keys that can be used for various functions. So a quick review of this. The AAA server, after successfully authenticating Bob, assigns Bob a pairwise master key that's kept in memory on Bob and the access point. Then the access point and Bob have a 4-way handshake to negotiate a pairwise transient key from which they can go ahead and subdivide that further and then start using that keying material for their encryption and data integrity checking functions. So we have all the pieces. We've got a AAA server, we've got a wireless LAN controller, we've got an access point, and we have Bob, the user, who's the supplicant in an 802.11x environment. We should also be aware that when Bob makes the request the AP is feeding all of that to the controller for those decision-making functions. And in the case of 802.11x, where we're referring the authentication over to a AAA server, it's the controller that'll be forwarding that packet from its IP address to the AAA server. We can just think of the AP as an extension of the controller and a controller as an extension of the AP. So our most likely options in a production environment would be to go ahead and use WPA2 and AES. And in this type of environment, it'd be an enterprise. Enterprise meaning we're using that AAA server. If we're in a home environment, we might be using WPA2 personal, which means we're using some type of pre-shared key along with AES. Another option would be WPA along with AES. Remember, it is optional, and that's if all devices support that. If you have some devices that don't support AES, they only support WPA but not AES, of course that wouldn't be a great solution. We also have the option of WPA plus TKIP plus AES. But if we enforce that, we say that's the only type of client we're going to allow to connect, what's the problem? You might have some clients that can't handle that complexity or that combination. So you want to validate that your clients, your supplicants, and the software they're using have the ability to implement the encryption that you want to do on that traffic. Then we have WPA and TKIP, which, again, based on your environment, might be the way you go. In a perfect world where every device supports the best security possible, we'd be using WPA2 and AES. I hope this has been informative for you, and I'd like to thank you for viewing.